Chapter 4, Diverse Architectural Styles. We're gonna talk about service-oriented architecture style, microservice, microkernel, and space-based architecture styles. So let's start with the first one, service-oriented architecture style. The basic topology of service-oriented architecture is a distributed structure consisting of mainly three parts. The first one is the user interface. The second one is separately deployed units. And the third part is the database. It's important to note that the services within this architecture style are coarse-grained. Means that if we have an application like this, we will divide it into few independent services, not too much, not like this. This will be microservice. هذا منين جاتنا كلمة coarse-grained. Second thing, service-oriented architecture do not require containerization. We don't need containers since it is independent from the platform. So no need for Docker. Because the service can work independently from any platform. Another thing is that the number of services is limited because the service typically share a single monolithic database. We have only one database shared by so many services. That's why we cannot create so many services like we usually do in microservice. Typically it is between let's say 8, 10 services. Minimum is 4, maximum is 12 independent service. One more thing, services are accessed remotely from a user interface using remote access protocol like REST, like SOAP, we will talk about this, like RPC, etc. Sometimes the single monolithic user interface, like this one, can be sometimes divided into many independent user interface, like this, or even like this. So here we are talking about a single monolithic user interface. Here we are talking about domain-based user interface, when these components are dealing with one specific domain. They will have one common user interface. Another domain will have one common user interface. Or we can have one user interface for each service, so it will be service-based user interface. And here we are approaching to microservice, but without reaching microservice, because microservice have different independent database for each component. Same for database. Single monolithic database can be broken apart into some separate database. For example, these three components share one database, and this component has one database. We can even have a separate database for each component, but here we are approaching too much to the microservice. Okay, second part of the service-oriented architecture is the web service, which is a part of the service-oriented architecture. Let's start with the definition. Web service is a software system identified by URI, which is a generalized form of URL, whose public interface and bindings are defined and described using XML. Its definition can be discovered by other software systems. These systems might then interact with the web service in a manner prescribed by the definition of the XML, using XML-based message conveyed by Internet protocols. This is the standard definition provided by the World Wide Web Consortium, but it is somehow outdated. I will give you an explanation to this definition with an update. So what is a web service? It is a program identified by URI, let's say URL, described often in XML. JSON also can be used, but XML is more common, offering various functionalities that other programs can discover and use. Discover it dynamically, so we can add service at runtime. Use thanks to protocol like XML, based on the exchange of messages transmitted by HTTP, FTP, SMTP, etc. This is a definition for lazy students. What is web service? It is a program accessible via the internet, often through XML message and transmitted via HTTP. Let's see how this works, the web service. So the first thing, let's see the component of a web service. We have a server and a client, of course, and we have UDDI, UDDI is a standard for service discovery. It's a place where we put the service. So here the server will start by publishing its service. Service can be for example translation, like Google Translate is a web service, can be a converter from Celsius to Fahrenheit for the devise or anything. So to put this for the public, first we need to publish it. Where to publish it? In the UDDI. UDDI is a standard for service discovery, where the client will discover the services. So the client will search for a service in the UDDI. We found a service, so UDDI found the required service and sent it back to the client. Now the client knows that there is the required service. The next step, the client will ask the server for the contract of the web service. And how can we talk to this web service? Which language? Not programming language. I mean, how can I interact with this service? The server will send the contract. For example, we'll say you can talk with this service using XML or using JSON. And this contract is written using WSDL, and WSDL is an interface definition language that describe the way the client can access to this service. Once the client know how to access to this service, the client can access it and ask for the service, and now we will use the protocol. For example, SOAP using XML is the most common protocol used in service-oriented architecture. So SOAP here is a communication protocol. Can be REST, for example, but REST is more used in microservice. Then the server will give the result using a SOAP. The client will ask again using a SOAP. The server will reply again using a SOAP. That's why the SOAP is a communication protocol. Let's talk in depth about XML. In fact, XML is a subset of the mother language SGML. SGML is a standard generalized markup language. Specify how a document markup language can be created. It allows the definition of a markup language for documents. So it is like a set of rules how to create a markup language. One of them is XML. So XML is a markup language that defines a set of rules for encoding documents in a format both human readable and machine readable. So the machine and the human can understand the XML language. Not like HTML. XML is more generalized and allow users to define their own tags. But HTML is not a subset of SGML, but it is an application of the whole SGML used in creating web pages. Of course, it is a specific application of SGML tailored for web documents, providing a fixed set of markup tags, not like the XML, which offers a dynamic tags. We can create our own tags, but in HTML, we have to use the tags. We have to learn HTML, but we don't, the HTML tags, I mean, but we don't have to learn XML tags because we are creating ours. Let's look at some code examples. This is SGML code example, and here the rules says that the type of the document is HTML, and in HTML must contains head and body. The head must contains the title. The title must be a text, etc. Some, like, let's say, some rules that must be applied to the HTML document. So when we say head, body, title, we have to use head, body, title, because this is the mother of the HTML. But in XML is a subset of the SGML. So here we follow the same mentality of SGML, I mean tags inside tags, but we can create our own tags. For example, here we said note, the note to Raj from Ravi with a heading, with a body. We can add many things here, but following the same structure of SGML. Let's compare now the three markup languages. The origin of the SGML is a meta language for defining markup languages. For defining this, for example, HTML is an application of SGML for the web. XML is an application of SGML, more generalized, not only for the web, can be used for many things. Regarding the flexibility, SGML is highly flexible since it can even define any markup language. But the HTML has a fixed tag sets designed specially for web pages, and XML user-defined tags used for let's say generalized use. Regarding the syntax, SGML is so complex and we can highly customize it. HTML is a simplified programming markup language, while XML has a strict syntax rules. So here in HTML we can allow mistakes. It can tolerate with mistakes, but here the mistake here will halt the processing of data. Why we use these three languages? The main purpose: we use SGML for complex structured documents, we use HTML for web documents, we use XML for data interchange, and here in our context we use XML to change data within the SOAP protocol. Diving deeper with the SOAP technology. SOAP is a technology to support the exchange of XML coded messages over the transport protocol, such as HTTP mainly. If we have a client and a server, they will communicate using SOAP protocol. This is the communication flow where the client uses the stub to make calls that are sent over the internet via HTTP protocol. A stub is like a representative for the web service, which is originally here, but it is represented here, letting you talk to the service as if it was the actual service. But behind the scene, the stub is the one who knows how to talk to the server. The client doesn't. The client will talk to the stub, but the stub knows how to talk to the server. Then the server receives the calls through the HTTP client, through the HTTP protocol, which passes them to the skeleton, and the skeleton then invokes the appropriate service within the server to handle the request and send it back to the client. The skeleton here is the part on the server side or service side that listen to what you want to do and do it, or dispatch it to the service to do it. So in general, a SOAP is a runtime engine, basically adds an XML envelope to an existing XML document. This is the XML. We will encapsulate it in a SOAP, and the SOAP will be encapsulated in turn within HTTP protocol. Then it will travel through the internet. In more details, the SOAP envelope contains two parts: the SOAP header and the SOAP body. The SOAP header contains the communication info, and the SOAP body contains the XML document. Let's take an example. Here we have a SOAP envelope. You can see that it is all written in XML, where in the body there are the data, the info we want to send. Get price of the apple, get price. So this is the tag get price. We will ask the service to give us the price of the apple. Of course, we will send the body with the header. The header contains information about the session and the routing, the security, the authentication, etc.